as you can tell, this ball has seen better days. But Casey, come here. And it's all thanks to my lovely friend right here. Let me toss this. So, as you all can tell, and I hope you're all excited as much as Casey is for today's video, as we're going to be looking at all the teams that are left in the NFL playoffs and trying to figure out, well, trying to predict who is going to win the Super Bowl. So please sit back, relax with your favorite snack, and let's get started, shall we? Hey, honors, hope you all are just having another fantastic day in paradise. I'm really excited for today's video because we're going to be using TensorFlow, Keras, and we're going to be trying to make some awesome predictions on the upcoming Super Bowl 2022. Now, the dataset I got up right behind me is a dataset that I scraped off of the internet, gathering all the stats on particular the two teams that made it to the Super Bowl from 1970 all up to 2021. Now, I am going to be raffling off this dataset, so if you want to get your own version of this dataset, go ahead and leave a comment down in the comment section down below. It can be any type of comment you want. It could be hi, it can be what is your favorite NFL team or your favorite Python module. Please keep it PG also, guys. And also, if there are two more things that you need in order to enter into this raffle, hit that subscription button as well as that like button to be entered into this raffle. Next Sunday, I will actually go through all the comments and randomly select one of them. So if you want a chance to win this dataset, go ahead and check out the comment section down below, leaving a like and a subscription, and hitting that subscribe button. Also, Islanders, for those of you who are brand new to the Islander community, welcome. My name is William McKeon, and this Islander community is all about making artificial intelligence accessible by using Python to learn applications of artificial intelligence through demonstration. Really, that's enough talk. Why don't we dive into making some really awesome predictions with TensorFlow and Keras. All right, so we're over here inside of Dataspell, and for those of you who don't know what Dataspell is, essentially it's just a shell for a Jupyter notebook, but allows you to be able to do a lot of the same cool stuff with a Jupyter notebook with the add-ons of a JetBrains IDE, something I really like to have. So the first thing we're going to be doing is importing all of our modules. Of course, we're going to have to import pandas as PD, and then we're going to import numpy, well, not numbers, numpy as np, and then we're going to also import, from sklearn.model selection import train test split. We're not going to have to import our community's Python package IR data cleaning, really just because when I was doing the web scraping process of this data set, I cleaned out all the bad information. So what we're going to want to do next is just import pickle. Now, what is pickle? Well, we'll get into that in a couple of seconds. But once we've done that, we're just going to say data equals pd.read CSV. Now what we're going to be putting within this is the file location of that dataset that I just showed you all on how to possibly win. So we're just going to be Command V. Oh, I forgot the little quotations, Command V, and then index column equals 0. We're going to run that one line and we're going to get a brand new line. And what we're going to do is just check out what's inside this information. So info, run this real quick. So total points, we have about 5 columns. Now you'll notice that we don't have the team names as well as the years. The reason being is because I don't want the data set to become biased based off of the team's names that's being imported, as well as I don't want the data set to become biased based off of the year that that team won. Reason being is because it may actually see that a certain team has been winning more consistently and say that and actually become biased towards that team. Instead, what I want this model to actually specifically look at is the stats for each team that made it to the Super Bowl from all the previous years all the way to 1970. So let's just take a quick look at what I mean, what this data looks like. Data.head. All right, now boom, boom, run that, and we can just see that it's total points is some float values, as well as points per game is also a float value. Points allowed is an integer. Total yards is an integer. And then who won is filled with zeros and ones. And we can confirm that by just coming over to data.whowon.values counts. And you can see that there's 52 zeros and 52 ones. That's perfect. That means that this data set is perfectly balanced between teams that didn't win the Super Bowl and teams that did win the Super Bowl. Now, why do we pick zeros and ones? Well, I could have easily just said true or false for these, but there are certain models that don't really allow you to be able to use true and false within the prediction values. So what we ended up doing to be able to get around that so that we can really use any model that we possibly would like, we just have the zeros and ones within this column. Now this column is going to be our Y value. So when we come down into the next data within the next cell, what we're going to say is X equals NP dot array, and we're going to say data dot iloc from all the rows, and we're going to say everything all the way to the last, before the last line, dot values. Now the reason why we're going to be ignoring that last column that we were just talking about that's filled with zeros and ones is because, like I was saying, that is going to be our Y value. So we're going to say Y equals NP dot array data dot iloc all the rows within the last column. All right, now we're just going to say dot values, and then we're going to be splitting this data up into the training set and the test set. So X comma train, X test, Y train, Y test equals train test split. We're going to say X, Y, and we're going to say the test size is 0. Test size equals 0.2. Now we're going to run this and it's going to split up all the data. We can just take a quick look at this. We're going to, I don't know what I just clicked. Take a look right here. X, let's say X train. Take a look at this. It's got some really good information on it, and there's only one thing. We really want to optimize this data set, and the best way to be doing that, there's a whole boatload of different ways, but I've actually been working on a Python module called classification. And what classification is going to allow you to do is actually build a data set based off of your information that you provide to it, as well as going to be using Keras Tuner to actually be able to optimize and find the perfect values you want for your data set. So what we're going to want to do, because it doesn't really work that well, because of how long it usually takes for a model to get optimized, a Jupyter Notebook is not really the best thing to be using, just because of how it's going to be, there's a higher chance of it crashing within a Jupyter Notebook than if we were to run this inside of the terminal. So we're going to do, in order to import all the X trains and the Y trains over to a whole nother script and be able to get accurate implementations of that optimization, what we're going to be doing is importing all that data as a pickle. So that's why we imported the pickle library, and essentially all it's going to do is turn all the X values and the Y values into binary values. So we're going to say with open, and we're going to call this file xtrain.pickle, and we're going to say wb, write bytes as file. All right, and then we're going to say, oh, did I spell with wrong? Yep. We're going to say pickle.dump, and the object we're going to be doing is xtrain, and we're going to be passing this into file. Now, when I run this, it's just going to be therefore turning all this information into a pickle file. So run this, it's going to turn all that information over, and it's now what we can do is come over to here, ignore all that. Where did I put you? You're going to be within January. Nope. Boom, boom, new Python file. We're just going to say super. All right, Python file. Make this small again. And then what we're going to be doing is we're going to be import pickle, as well as from this file I got over there called classification new. This Python module that we're talking about with the optimization and everything is currently not on the PyPI website, but I will be leaving a GitHub repository link down in the description bar down below, just in case you want to be fiddling around with this Python package. But from classification, we're going to import classification. There's a whole boatload of stuff we're going to be eventually able to do with this particular module, but for right now I'm still working out the kinks. But what we can do is actually use this model to find the most optimal classification model with Keras and TensorFlow. But instead of again reinventing the wheel, what we're going to be doing is do Command C, come over to here, and we're going to say Command V. But what we're going to end up doing, now what we have when I run this file is all the same information within this Jupyter notebook we have now over inside this other script. Now what we're going to be wanting to do is we're going to want to create a brand new instance of the classification. So we're just going to say class if, let's just go with that, equals classification. Now what we're going to be want to do is we're just going to say tuner equals, oh wait, I need to pass in X test and all that fun stuff. Luckily what we can do is just come over to here, copy you, come back over to here, paste you there, run. Well, no, I can't do that because of the thing. So CLA classif.opt, and what we're going to want to say is project name, we're going to say super. All right, and then what we're going to want to do now is optimizer. All these values do have default values, so you can just run it how it is, but I want to make sure that we get the most optimal values we can get. So optimizer is going to be Atom, as well as we're going to be using SGD. And the next thing we're going to be wanting to do is the loss function. So loss equals, and then I always mess these up, so it's going to be, give me a sec. I'm going to pause the video real quick. I'm going to get all these names and I'll tune right back in. All right, so these are all the loss functions we're going to be using. Keep in mind, the classifier is actually a built-on of Keras as well as TensorFlow and Keras Tuner. So we're going to be able to use a lot of the same stuff you can use any of those three modules for. And so, for instance, we're going to be using a categorical cross entropy for one of the tests, sparse categorical cross entropy, as well as the Poisson loss function. Now there's one more input that we're going to be adding, and that's going to be the max layer. So I want a max layer of about, let's say, 4 layers. I don't want anything too crazy for this one particular, but what we're going to be doing is just non-interactive. So what we can do is now just run the file, and it's going to take it's going to take a while for this to load. So sit back with your favorite snack, maybe go get a coffee, and this thing's going to be loading. And once it's all done loading, I will tune right back in with all of you. All right, so we're back, and we have the most optimal we have all the information to create a really optimal Keras classification model. Now, instead of looking at it inside this run file, because by default the classification.opt module will actually produce this result summary for you. What we're going to want to actually do is we're going to come back over to this Jupyter notebook we have over here, and we're going to actually call upon that pickle file that we saved all that information in, so that we can actually make some, it'll be a lot easier for us to actually create this Keras module. So what we're going to be doing is we're just going to copy this, and we're going to paste this in real quick right there. I'm going to copy this, delete that, and we're going to change dump into load. W is going to turn into an R. We're going to paste that in just like that. We're going to go bada bing, bada boom. And now we're going to want to be able to see the result summary. This is going to show us what variables we should use with the particular data that we produce, that we gave the classifier. And it's going to show us the same information as what's going on right within this file. So all that we have to do in order to do that is we're just going to say tuner.res results summary. Run it just like that, and what we can see real quick is that it's going to be showing us the top of this, of these results, and the top model is going to be the most accurate model that we can possibly produce. So let's scroll down all the way down to the score. 76, that's really good considering we're making predictions on human behavior. A 76, almost 80% accuracy is really, really good. Now, what I originally want with the classification model that we use to actually find all this information, I'm working on a way for all of you to be producing a lot simpler way to actually be able to create a TensorFlow/Keras model with the information that's being provided here, so it's more accurate and more accessible for all of you islanders that are just getting into TensorFlow, machine learning, artificial intelligence. But for right now, we're actually going to be building this model by scratch, from scratch. So what we're going to need is import well, actually, we want to say from TensorFlow, import Keras, and then what else do we need? That's really it. So what we're going to also want is, yeah, we're going to create a model called model equals Keras dot, what are you? MODELS dot SEQ. Run that. All right. Did I just spell one of these wrong? No, we should be all set. So what we're going to want to do is we're going to actually flatten this information, and that's just, it's something I like to do with all classification models. You don't have to do it with this particular data set because it's a data set, not an image. But more often, you're going to be using flatten for a image classification model. But I just like to do it just to keep all my models relatively the same so it's easier for me to debug. So I'm going to say model dot add. We're going to say Keras dot layers dot flatten, bada bing bada boom. We're going to run that, and we're going to say model dot add, and we're going to say Keras dot layers dot dense, DENSE, and we're going to, the inputs, well, the unit for this one is going to be 51. So we're going to say 51, and the activation is going to equal a reuse activation. Run that, and then we're going to add a dropout layer. So model dot add Keras dot layers dot drop out, and we're going to say a dropout percentage of 0.2. All right. Now we're going to be running the next several layers. It's going to become really, really repetitive. And basically what we're going to be doing is just saying model.add, Keras layers, yada, yada, 51, activation. It's going to be changing based off the results we got for this. But once we get to the last layer, you're going to have to do something else. And I'll tune right back in once we get to that layer. So, all right, so I'm back. These are all the layers that we just defined are considered the hidden layers of our neural network. Now we're going to be producing the output layer. The output layer is going to actually be a lot different than all of the layers that we just mentioned. The reason being is because it's going to be using a different activation than what we have been using, which is reuse as well as soft plus. What activation we're going to end up using is we're just going to say model.add Keras dot layers. I'm going to copy this. Command C. You know, Command C is a programmer's best friend. And also, it eliminates programmer's headache. And I just screwed it up. Command C. Command V, and we're going to change this to the amount of classifiers we have within our data set. Well, the amount of classes we have within our data set, which is 2, 0, and 1. So we're going to be putting 2 for the unit, and the activation is actually going to be soft max. Right? That's the output layer. Well, that's the activation you want for any classifier's output layer. So when we run this, the next thing we have to do is actually compile this model. So we're going to say is model.compile, I think I spelled it right, and we're going to say optimizer equals, which one are we going to be using for the optimizer? Atom. So we're going to say ADAM. For the loss, we're going to say is equal to, I'm just going to come back over here because I cannot spell this one to save my life. Command C and then Command V. Now there's going to be one more thing we're going to have to add, and this is particularly just for classification models. We're going to say metrics equals accuracy. All right. Now we're going to run that one line, and we're going to say model dot fit, and we're going to say x train, y train, and then we're going to say epochs, epochs, and the amount of epochs we want to use is going to be specified here. Now, initial as well as epochs right here. Initial is meaning that essentially we create a model, and then we had an additional model applied upon that previous model. We're not going to get into all that stuff. That's pretty advanced stuff to be doing. This is just really going to be getting you guys into the idea of using TensorFlow and Keras. So what we're going to end up doing is just combining the 100 and the 25 to be 125 epochs. So what we're going to be doing is equal 125. Now what we're going to say is validation data equals x test and y test. So now when we run this, we just get to sit back, relax. It's going to be running 125 epochs. Once it's all set and ready to go, I'll tune right back in. All right, so I kind of expected this, and that's because we're actually, so what the optimizer is specifying within, well, when using these when using these optimizers is actually a type of non-supervised machine, artificial intelligence model. That's really high up, that's really high level, and it's something I don't really want to go into that far in depth in today's video. I really want to keep it within the supervised learning spectrum. So what we're going to be doing to get closer results than what we got within actually building that model by scratch is actually another way. We have the ability to use the tuner that we turned into a pickle to import into this file to actually be able to build a model that's the most accurate possible model we can get. And within my notes within this classification new, we actually have the ability to do that. So what we're going to do is copy this over to this brand new cell. We're going to do Command A. Got a bing, bada boom. Run this. It's going to wait. What? Oh, I need to get rid of cell. Now we can actually run that one line. It's going to be running quite a bit real quick. So it's going to actually it's a lot quicker than you're going to think. But I'll tune back in once this is done figuring everything out. All right, so it's all brand new, set up, ready to go. Let's check out what is the accuracy of this model going to be. Run that real quick. 52. I think that's about as good as we're going to be get while keeping it within the supervised machine learning spectrum. So what we're going to be doing next is actually making some predictions. In order to do that, what we're going to need is a specific data set that I created, and the file location we just need to get real quick. This is going to be the playoff standings. We're going to copy that path location. Now, this is the standings of all the teams that are currently within this video recording that are still in the playoffs. So what we're going to be doing is say predict, actually let's say current equals pd dot read csv within the file location of this. And I don't know if I need to remove the index, so let's just say current dot current, and let's just run you. Yeah, I need to say index column equals 0, run. And now what we're going to want to do is I kept the teams in here because when we get some sort of prediction out of this model, we're going to be able to need to know what teams we're talking about. So we're going to actually take out the teams, and then at the end we're going to be putting them back in. So what we're going to be doing is just going to create a list called teams equals I for I in current dot teams. Run that, and as you will be able to see, this is just a list filled with all the teams' names. Now what we're going to want to do next is just say current dot drop columns equals teams, and we're going to want to keep that in place. True. All right, now run that, and I'm just going to convert the rest of the data into a Numpy array. So we're going to just say current underscore np equals np.array of current.iloc from all the rows and all the columns, because we don't have to worry about the y values, because the y values is what we want to predict. So we're going to run that, and we're going to say model dot. Well, actually, no, because at the end of this whole thing, we got a different name. So we're going to say hypermodel. Like I was saying earlier on in today's video, this classification method will eventually become available for all you Islanders. Currently, there is a GitHub repository that you can use to install this into your local machine, and you can mess around with this as you please. Just keep in mind this method is not, well, this Python API is not finalized. So paste that in, dot predict current underscore NP. Run that, and it's going to show us all these values. This is going to be the percentage that team actually has of winning based off of its current stats. It has nothing to do with the team's name. It just has to do with the stats that we were mentioning, which are right here. Total points they have scored so far in this season, points per game, points allowed, in total yards. So what I want to actually do now is create a brand new, I want to create a pandas data frame that will allow us to be able to actually see what are the names of the team. So we're going to say is, we're going to actually create a dictionary called predictions equals, we're going to say teams I for I in teams. Now the next thing we're going to want to do is actually we want to save this as, we're going to say pred equals that, and I want to add now run this. We're going to convert this into a pandas data frame by just saying predictions underscore PD equals a PD dot data frame, and we're going to pass in predictions. Now let's take a look at what possible teams will be winning could possibly win the Super Bowl this year, 2022. So we're going to say predictions underscore PD, run that. Now what I want to do is I actually want to end up sorting the values based off of the possible win. So SOR sort values by, we're going to say possible win. Let's see which team has the highest probability of winning. Actually, I want, the bottom ones. So the Buffalo Bills have a 26.23% of winning, while the Las Vegas Raiders also have a high chance of winning too, and the San Francisco 49ers. You all heard it here. Thank you all so much for watching. Again, if you want a chance to win the dataset that I currently use to make these predictions, again, these are predictions, not actually what's going to be happening. Go ahead and leave a comment down in the comment section down below. It can be anything you want. Your favorite NFL team. It can be your favorite Python module. All right, just leave it down in the comment section down below, as well as hit that subscription button, as well as that like button, to be able to win that, to be able to enter into the raffle of winning that data set. Thank you all so much for watching. As always, if you want to learn more about artificial intelligence, go ahead and check out the videos popping up on the screen. As always, don't forget to laugh. It helps with the programmer's headache, and I'll see you all in the next video. Bye.